can actually watch all the sessions. So here is the schedule. As you see, there are quite a few of them. This is all this year sessions. And yeah, on every framework or on every change or whatever, they're offering you really detailed explanation on what changed. Yeah, first keynote and State of the Union is two introductory events where they tell in general what happened so that you have an overview. And then every day there are a bunch of different sessions on everything what changed. So yeah, I can definitely recommend you looking through it. So here's how the detailed overview of some session looks like. And if there was any code presented, you can also see it in this section. Yeah. And since we don't have anything scheduled yet for one of our lectures in a couple of weeks, maybe if we still have time, we could look through something what was only recently introduced in Swift. And now we can come back to the slide deck. Yeah, as I mentioned, we are finishing with the UI kit and specifically how the data is displayed in UI kit or data is processed or handled. First, we are going to look again into the UI table view, but more detailed. As you may remember, last time on my lecture, I showed you some app having a few different UI table view screens. And yeah, let's discuss how exactly it works. UI table view displays data in one-dimensional table, and it's a subclass of UI scroll view. So the scrolling is already there. It can be static or dynamic. So dynamic example of a UI table view would be something what you're fetching from the database or from the server, like, I don't know, users list, and then displaying in the table view. And static, it can be something like maybe settings screen or something like that, something what doesn't really change, and something what you don't need to fetch from somewhere. And static UI table view, static content for the UI table view can be also constructed just in the storyboard. So you can just drag and drop all the views which you want to have, and then you wouldn't need to have the data source. Yeah, you customize UI table view using delegate and data source protocols. It is very efficient with large sets of data because it uses the approach called recycling. So let's imagine you have a UI table view with 100 cells or 1,000 or whatever. So you want to display 1,000 elements, but actually UI table you won't show actually 1,000. It would show the amount of cells which can fit on the screen in the view. And then when one cell is leaving the screen, it will be reused somewhere, for example, down where the cells are appearing. So it actually really improves the performance because you don't need a large amount of views for that. As you saw in the demo in the last lecture, there are different kinds of UI table views. It can be plain, grouped, static or dynamic, as I mentioned. There can be sections if you want, and you can customize the cells and even make your UI table view have multiple types of cells. Here is an example. On the left side, you can see the static UI table view, so the one which you can create in the storyboard. And on the right side, it's an example of dynamic one. So this is contact list, and yeah, you may want to fetch it from the database or from whatever. And as you see, there are also sections here on each letter of the last name. Another example of the different ways you can display cells. There are different cell styles, and there are different accessory types. So if you want to display some standard view on your cell, you can just use accessory type, either from storyboard or from the code. It's really easy. Yeah, but you always need to follow the guidelines on what these buttons need to do. So for example, when a user presses on the I button, usually they would expect something popping up and maybe showing some detailed explanation on what this is doing. And if there's an arrow, there is an expectation that another screen would be opened with the detailed info on this cell. And you can customize a row. Instead of using a standard one, you would just need to subclass UI table view cell and provide the content for it. You can either, again, you can either do it with storyboard, so exactly like you do for the view controller. So you create view controller in the storyboard, and then you create the class, and then you just connect the outlets. And you can do the same thing with the cells, or same way as with view controllers, you can not use storyboard at all and just create all the constraints in the code for your cell. But always don't forget to register your cell type to the table view. Yeah, as I mentioned, you can create the XIF file for your cell, then Swift file, and in a similar way, you can just connect the outlets. Don't forget to register. And yeah, if it is a cell which was constructed from the XIF file, you need to instantiate it this way using UI-NIP class. And this way you can actually instantiate your cell. Now we're going to talk about the UI table view data source. So the delegate, the protocol which actually lets the UI table view know how many rows needs to be there, how many sections. So all the customization is happening via the UI table view data source. So if you want to override any methods from the UI table view data source, just pay attention to the label of the second parameter, and you will see what exactly what information exactly you're going to provide. So this one would be responsible for the number of rows in a specific section. And if you want to customize the amount of sections, you can override this method. By default, it would be just one. If you want to have more, you need to implement this method. And you always need to implement the method to tell how many rows are in your table view. There are more methods. For example, if you want to set a title for a header or a footer, so each section of your UI table view can have a header it's a view which would be displayed on top of the section, like in the contact list, or a footer, which would be displayed below the section. You can also have both of them. And if you want, you can also have header or footer for the entire UI table view. And yeah, I didn't mention, if you want to have a custom view for header or footer, you can use the same approach as with custom cell. So you would create, for example, a zip file, you would create Swift class to connect the outlets, and you would then register it to your table view, same way as with the normal cells. There are also a lot of methods for editing the UI table view content. So if you want, for example, you can move the cells or you can remove them. And to let your table view know that that can happen, for example, you can implement can move row add method to enable this behavior. Same goes with the editing. Then another important protocol is UI table view delegate. This is the way you can tell UI table view how to act on some events happening from the user side. So for example, via UI table view delegate, you would be notified that the row was selected, and then you can do something about that. For example, open another screen or do some custom behavior. Yeah, but there are multiple methods like that. I would always recommend to check the documentation, because there is quite a lot of stuff and we cannot fit everything in the slide deck. And similar way you did it for buttons to open another view controller, you can use segues for UI table view cells. Yeah, actually works exactly the same way. You can just do that in the custom cell class. And when you actually going to navigate to another view controller, you can provide some custom data to display something. These are also two important methods. When something changes, you can let your table view know that it should update the UI. Reload data method would completely reload the whole content, and it is rather heavy because there is quite a lot of work that needs to be done to do that. Yeah, don't really do that often unless it's really necessary. Instead, you could use reload rows, and if you know which rows specifically were changed, their indexes, and then you can just reload this section of the UI table view, and it is way less impact on the performance. You can also tell UI table view the size of your cell, so the height of your cell. It also helps the table view performance-wise if it doesn't need to calculate it itself, and if you can know the size of your cells, then you can also do that via the property row height or via the delegate. And now we're going to talk about the UI collection view. This component is really similar to UI table view. So the API is really similar. You can use it exactly the same way. Same as UI table view, it needs to have UI collection view delegate and UI collection view data source. And if you want to customize the way the cell is displayed, you can create a subclass of UI collection view cell. The difference would be is that you can really customize a lot the layout, the way these cells are displayed relative to each other. By default, you can use flow layout, so the one which would display the cells in a grid. You can also subclass it to introduce some custom behavior to make some more complicated layout like here. You can also, the cells in a UI collection view also can have headers, footers. Works really similar way. And now let's look at the example. So as you see, exactly the same way as with the UI table view, we have a custom cell, which is a subclass of UI collection view cell, where we have just a text label. Here is the zip file, and it takes some time. Yeah, here it is just a label. And then, just a second. I want to show my simulator. Let's start though. Here we have the view controller. Here's the UI collection view outlet. As you see, it's just a normal UI view controller with delegate data source and delegate flow layout. We're going to talk about it a bit later. But the setup is really similar to the way you do with the UI table view. As you see, first we need to register the cell. Yeah, same way. Then we set data source and the delegate. We want to have just one section. Here's the amount of cells we're going to have. Then we provide the custom cell for the collection view. And here are the methods from the flow layout delegate, where we can specify, for example, the size of the cell. Yeah, here's how it looks right now. As you see, we didn't really specify the amount of columns, but we specified the size, and we set the minimum spacing between the lines and between the items. So, for example, if we say 0 in both places, and here we can say collection view, then let's divide it by 5, which should create us a layout with 5 columns. Yeah. As you see, really easy, and the setup is really similar to UI table view. And here's the storyboard. Nothing really special here. So we set flow layout, and that's it. Everything else is customized via the view controller. The slides. And now let's talk about custom views. So you already used standard views from UIKit, for example, buttons, labels, input fields, and you can also create your own custom views. There are a few different situations when you may need to create a custom view. For example, when you need to display some custom drawing on the screen, so something what the standard views cannot provide. Another situation would be when there are multiple places in your app where you use the same layout, let's say it like that, for your screen. So for example, there is a profile view for a user, and you are displaying it in multiple places in your app, and it's displayed exactly the same way. Let's say there is an image view, which is displayed in the center, and the name and last name, city, and whatever is displayed exactly same way in all these places. Then it makes sense to create a custom view out of it. So although there is no custom graphics there, but it's just a reusable set of the standard views from UIKit, for example. And yeah, then it makes sense to create a custom view so that it's easy to reuse it without setting up everything multiple times in different places. And another case would be some custom touch events handling that would be also a reason to create a custom view. If you want to draw something in your custom view, you need to override draw rect method. And there you would actually use a set of different operations like draw line or draw rect or whatever to make your custom view. And you should never call draw rect directly. The system will call it when it is necessary. And if you want to redraw your custom view, use set needs display method. Yeah, here are a couple of examples how you can draw a custom graphic for your custom view. First way would be using core graphics. You need to obtain context, core graphics context, and then again using different operations, different shapes, construct the graphics. You can also customize the colors, fonts, anything you want. And the UIKit way would be using UI Bezier path class, which again gives you a similar functionality. You can draw different shapes, and you can draw more complex curves, Bezier curves. Actually, you can do this also with core graphics. What is Bezier curve? Basically, it is a curve which is determined by one or more control points. So here is the starting point, end point of your curve. And these two are control points. And as you see, depending on the location of these control points, the shape of the curve is going to change. Yeah, I think he was French. It was French engineer who came up with the formula for this curve. And back then it was used for designing the cars. So the shape of a car. Just a second. And now it's very commonly used in computer graphics to describe the curves. And actually, I wanted to show you an example what you can do with Bezier curves. Actually, it was here. for example, this library, I did it on Android a few years ago. And that's an example of what you can do with PC Curves. It would be actually exactly the same way on iOS. There is not so much difference between the graphics API, what you can do between the platforms. As you see, to draw this kind of behavior, I used two cubic Bezier curves. So the top one until the touch horizontal line and the bottom line. I can quickly show you. So yeah, as you see, when I'm drawing the component, first, I'm drawing the straight lines to make the how to say that. Let me just open it here again. So the horizontal lines would be for the moment when it's actually moving this part. And then I'm drawing two cubic Bezier curves. Yeah, and depending on the moment of the animation, I'm changing the values for the for a few properties so that it actually can be can move like this. Another example would be this one. Yeah, to be honest, completely useless thing, but it was fun to try out the Bezier curves. So when you press search, as you see, there is a Bezier curve to describe this behavior. But yet it can be fun to try out. So this is on this slide. This is an example of the cubic Bezier curve, because there are two control points. If there is just one control point, that would be quadratic curve. Yeah. This is an example of, this is a really simple example, just the straight lines, but you can also use UI Bezier path class for that. As you see, you can move, you can add different shapes, you can change colors and widths of the lines, and you can fill the form, anything you want pretty much. Yeah, this is an example of the custom view. So you create a class, name it as you want, and then you make it a subclass of UI view over some other view. And in the draw rect method, you can draw something. If you are making a custom view of just like a set of default views from the UI view, UI kit, then you don't need to draw rect method at all. You can just set the constraints like you would do in the view controller. Yeah, there are a few other important parameters of view. To set the colors in the UI view, you normally use UI color class or CG color in specific cases. The specific cases would be if you use Core Graphics framework. So UI would be UIKit and CG Core Graphics. Yeah, depending on what framework you use, you can use one or another, but the idea is the same. A bit later, we're going to talk about the asset catalog, where you can store images and colors for your app. You can change the background of your UI view. Oops, so far away. Change the background color. You can also change the transparency, yeah, if you want. And if you can just hit your view. So instead of I don't know, deleting all the constraints or deleting the view, you can just hit it, which would be way more efficient. So if it's possible, it's better to go for just hidden the view if you need to temporarily not show it. Yeah, there are a couple of ways how you can display text in your view. So the most common way and what you would normally do is using UI label to display it. Or if you want to do something more complicated, you can use NS attributed string, which we're going to talk about in the next slide. And you can just draw this text in your custom view. Same goes for the images. Normally, you can just use UI image view to display something. But if you want to draw an image in your custom view on the specific coordinates or something, you can do it this way. Yeah. When you want to create some custom string would be, for example, a string containing some icons in it. So you can even, somewhere in between some letters, you can put, for example, icons from your asset catalog. Or if you want to use some custom formatting for the string, so underlining, yeah, anything you want actually. In this case, you would need to use an S attributed string. So when you will be working on iOS, you could notice that some classes names start with NS. These classes are Objective-C classes, and this naming is kind of a heritage. So there was operating system called Next Step, I think, and at some point it was bought by Apple, and later on the foundation of it, macOS was built. Back then they used, of course, only Objective-C, and some of the classes were named like this because they were taken from this previous operating system. And now in Swift, you still can use Objective-C classes when you need. Yeah, so if you want to change some formatting for a range of your attributed string, you need to calculate the range, so the start position range, and you can add an attribute. So for example, underline style for the range of your string. And then you can just use this string to set text to your UI label. And when you create a custom view, you may want to still use it from the storyboard. In this case, you may want to use the interface builder designable and interface builder inspectable to actually be able to see the preview in the storyboard of your custom view and configure some attributes of your custom view. So for example, you create triangle height property, and if you mark it as inspectable, you would be able then to customize this value from the storyboard, like you do for the default views from the UI kit. But yeah, it doesn't really happen often. I would say drawing itself doesn't really happen often. For the normal applications, without any gamification, without any custom views. Normally, you don't really need to do that. You would just use standard UI kit views and maybe customize their appearance a bit, but you wouldn't draw something. UIKit also offers a few different gesture recognizers. It's a really convenient way if you want to implement some custom behavior for your UI. So imagine if you have some gallery app, like photo app, and you want to zoom the image when the user uses specific gesture. And then you can just use gesture recognizer, and you won't need to care about the low-level event handling. You would just get some method triggered when the event actually happened, and you don't need to determine yourself whether this event happening or not. Yeah, let's look at the examples. As you see, there are a few different ones. So for the tab, pinch is the one called when you are zooming an image, for example, or any other view. For example, you may have UI collection view, which could zoom the cells and something like that. Yeah, pen gesture recognizer, swipe, rotation, and long press. Here is an example how you would use it. So you would just instantiate the recognizer, pass the target, would be often view controller, such as self, and you need to specify the action. So you put the selector for some method, and this method will be called every time a user taps on this view. If it was pinch gesture recognizer, then the method would be called every time user does specific gesture. Yeah, really easy and convenient. And now we are going to talk about the storage options on iOS. We are going to discuss property lists, user defaults, and application preferences in this slide deck. And there will be a separate slide deck on the core data. I think you will look through it in a couple of weeks, maybe a week. And other options would be CloudKit and Keychain, but they are not going to be covered in the course. Yeah, property lists are a convenient way to store a small amount of data. Property list is basically a file with plist extension. This is pretty much just an XML format, but in Xcode it can be previewed nicely in the UI. But yeah, that's basically a key value based file. The values for the keys must be only classes. So it would be array, dictionary, string, data, date, number. So not too much of a variety, but depending on the use case, it can be really convenient. For example, you wouldn't store in the property list something what can really grow. So you would store there only the information which has this kind of static size. Let's say if you're talking about training app, saving workouts which a user did wouldn't make sense. It wouldn't make sense to do it in the property list because the amount of data grows. So this is the property list would be convenient for some kind of configuration for an app. Another option is user defaults. I would say it's really common to use user defaults to save the values, for example, from the settings screen. So if your app has a setting screen to set up some behavior in your app, it would make sense to save these preferences in the user defaults. So for example, if it's possible in your app to pick the mode, like light mode or dark mode, you would just save the user choice in the user defaults. Yeah, really easy to use. Here is how you access the user defaults. You can set a value for a key and then retrieve this value. That would be always optional, so you need to unwrap it. You can store different values in there. You can also even store, for example, custom classes. If your class conforms to a codable protocol, we're going to talk about that in the networking slide deck. But yeah, technically it is possible to save the custom class. And as long as the app is installed, it would be persisted. Application preferences. So there are two ways on iOS to define the settings. The most common way would be to actually make settings screen in your app. I would say it's also the most preferable way because for a user, it's way easier to just switch to the screen and set up your app. But some of the settings which don't really change often can be also placed in the phone's settings. But again, it is not super convenient because then a user needs to leave your app, open settings app, find the app there and set the settings. So I would say settings inside the app is the most common approach. But here is how you can add the settings to the phone settings. You need to create a new file of settings bundle type. So you can just choose the template when you create a new file in Xcode. And then again, it is a property list, so plist file where you can add the settings which you want to show up in the settings for your app. Yeah, for example, what is this exactly? Yeah, you can, for example, let the user enable something or disable. So this is enabled preference. I guess it's this one, yeah. Yeah, toggle switch. As you see, the type is toggle switch. Title enabled. Here is the identifier so that you can use retrieve the value for the setting later on in your app. Yeah, and here is the item for the slider. So for this one, as you see, you choose the type slider. You need to again set the identifier so you can retrieve the value of the slider. You set the minimum, maximum value, and the default one. That's it. And now we would start with the localization. Yeah, iOS app can support multiple languages. And normally when you use strong localization, you mean the translating your app in different languages. But it can also include some other regional differences in the UI, but we are going to talk about the language. What you also always need to remember about in your app, if you use calendar occurrences, there are of course differences based on the region. How you can localize something. So you need to create a strings file. and name it localizable strings. And then Xcode will recognize it as a translation file. There you would store your texts for your app as a key value. Let's look at the example a bit later. And then when you have this file, you can localize it to multiple languages. So the default one would be, for example, English text. And then you would press localize. So this button would appear if you open the localizable strings file, and on the right side you would see this tab. And if you press localize, you can press select different. Where is the descriptions? You can pick the languages which you want to localize to. So you can also choose which files you want to localize. So localizable strings is not the only option. If you have storyboards, Xcode can also localize the storyboard files. Also really convenient. And then when you have multiple languages, you would just see all these files in the localizable string. Yeah, here is an example. If you used a storyboard to localize the strings, then Xcode will generate this strings file, which would be named like the storyboard which you localized. It would use some identifiers of the labels or which you use to set the text. You don't really need to change these values. They are going to be generated by Xcode. You only need to change the translations yourself. Let's say if the app is rather small and you develop it yourself, you would just manually set the translations for each key. But if it's a bigger company, a bigger app, so for example, at Trendtastic we support, actually I wanted to show you. We use a tool called LingoHub for localization of our apps. So we support, I think, more than 10 languages. Let's see, just a second. So here is all the languages which we support. English is the default one, and based on the English file, we translate all others. So our language specialists do that. Yeah, this tool really simplifies for the language specialists to do that, because they don't need to directly work with the strings files. They can just use the UI to translate the files. So they go to the editor and pick the language. So there is one language specialist for each language. And then, here's the English version of the string, and they need to translate it. And then when the translation is done, we can just pull these updated texts, and they would be properly translated to French in this case. So the files which we would download from LingoHub, would be updated values in here. The keys should always be the same in the different languages files. Yeah, so here's an example. Here's the strings file in English, and here's the strings file in German. The key is always the same, but the translation would be different. And yeah, then you can run your app and see that the strings are translated. And in Xcode, you can also choose that as the launch parameter. If you press Option, click on the Run button. And yeah, I actually recommend you to look through the options here to see what you can actually do. You can, for example, set a default location for the app region. So depending on the app region, for example, currency and calendar would change. So let's say if you pick Austria, the currency would be euro, but if you pick United States, it would be if you pick United States, it would be dollars. If you pick UK, it would be pounds. Yeah. Also, for United States, the calendar would be different. The first day of the week would be then Sunday. So it's really always recommended to rely on the standard API to determine currency and, for example, first day of the week, and not to try to calculate it yourself. You should always rely on the region settings of the user. And here you can pick the language. And yeah, if you pick German, then the app would be translated in German. If you pick some language which is not supported, then it would fall back to the default one. So in our case, it would be English. Yeah, here's the screenshot of it. And now we're going to talk about the app configuration. But I would ask you to have 10 minutes pause, and then in 9:55 we would continue with that. See you in 10 minutes. So let's continue with the asset catalog. Let's first look how it looks in Xcode. If you open the assets in your project, you will see that. In the asset catalog, you can add multiple resources. So first, the most important one is app icon, and we are going to talk about it a bit later. But now I want to show you, first you can add images to the asset catalog, and depending on the resolution of your of the user's device, different resources will be picked for this image. So when you access the image from the code like this, UI image named and then the name of the file, depending on the resolution, the system will return different size of the images. So it's a good practice to have at least two images for bigger sizes. The smallest one is not really much in use now. Then you can also add a color, and you can customize it for the dark mode. So if you set all your colors this way, and then your app will be really easily switched to dark mode without any issues. So it's also recommended to do, but not all apps really support dark mode easily. And here you can just drag and drop into these cells, and that's it. Yeah, it supports different types of the files, and you can pick colors. And here's an example with the app icon. Yeah, as you see, you also need to provide a lot of different sizes. Yeah. Actually, it's not that complicated as it looks. When you use your designer uses some editor, usually by default they support exporting to the set of all these sizes. It is recommended to provide all the sizes to get the best quality for each size. And if you don't provide all of them, I'm not really sure if the review which is happening when you submit your app on the Apple Store, I'm not sure if they would just approve it. But the App Store review process is always a bit of a lottery. So one time they can approve it and not approve another time. Yeah. Yeah, we talked already about property list files, but there is also one specific property list file, it's information property list, which contains all the information from the general capabilities and info tabs. So if you go here, everything what you specify in here will be stored into info list file, this one. So let's say if here we said the version is already 10, then when we go to the info list, it should change. Bundle version is bundle version. Let's see here. So as you see, it's just an XML file. It didn't get updated. Let's go in here. Let's do something here. So you can, for example, add more properties. Let's change this one. And then when we go to the list, yeah, here it is. Yeah, basically it contains all the information about apps configuration. So this is just a demo, but in the bigger app, there would be more configuration stored in here. And yeah, prefer editing it not from the info list itself, but rather from the designated tabs to not make any mistakes. Yeah, as I mentioned, it contains all the properties regarding the app capabilities, all the permission strings, URL schemes, which can be used by other apps to navigate to your app. Yeah, can be a lot of different stuff. Yeah, the app icon must be provided to display on the device's home screen and in App Store, or when user receives a push notification, there also should be a small icon there. Yeah, as I mentioned, you need to provide quite a few resolutions, but normally it's not an issue with some image editing tool. Also, many apps have launch screens. So this is basically a really simple screen which doesn't have view controller. It actually cannot have view controller. It's basically just if you use often just one image, a logo of your app, which appears for a few seconds before your app starts. Yeah. So basically this time used to prepare everything for the initial setup. And here is the link to the Apple guidelines for the user interface. I would really recommend you to look through it if you decide to publish an app yourself. You need to follow these guidelines first because they make your app understandable and predictable for a user, so it's more convenient to use it. But also, Apple checks if your app follows the guidelines while doing the review. So if you're doing something wrong or your app looks bad or something, they can just decline it. So for example, there are guidelines on the app icon. There are specific recommendations what you should and shouldn't do. So for example, you shouldn't use screenshots as your app icon because it makes it not that clear what is going on there. Yeah. So basically you can find the recommendations on any view which you use. So I would say it's just useful to look through it briefly if you decide to publish something to avoid being declined from Apple. And as I said, it's also important for the user so that the way your app looks and behaves feels familiar and understandable for the user. And we are actually done with this slide deck. Does anybody have questions on the topics which we discussed today? If not, then I would ask you to do two tasks. I will share with you now. You don't really need to show the result or show your solution. I would just ask you to do it, to try it out yourself and to see if you have any questions on that. And yeah, let's take 20 minutes, maybe 25 minutes for that. And then we'll continue with the next slide deck. So in the first task, you would need to create a view controller with the UI table view. Don't forget to register the cell type for your table view. Just use the default one. You don't need to make custom one. Also make your table view display 3 sections. So today, tomorrow, and later. And put a few to-do items in each section. And also use accessory type for the cell to display the check mark. So for example, I'll just quickly show you. So when you create the cell to return in the table view data source, you can just say table view cell accessory type checkmark, for example. Or you can also do that in the zip file. So if you select your cell view, here you can pick the accessory type. Yeah, and in the second task, it would be just to reuse the same storyboard and maybe add a few labels with some texts and to try to localize the storyboard. Does anybody have questions on the tasks?
Are the slides already in the e-learning platform?
Sorry, where?
On the e-learning.
I will just quickly check. If not, I will upload it.
Okay, thank you.
See? It is there, but it is hidden. Just a second. Yeah, now it should be shown. Yeah. So let's take maybe 25 minutes for the tasks and let me know if you have any questions on them.
I have a question.
Yeah.
Or I've a problem. That's that's the right pronounce. So my storyboard is all the time black, and I can show it to you in another project. There I get an error. Where is pin? So, and here is the error: failed to render and update layout status for view controller.
Could you please show me the structure of your view controller? So yeah, just open what is inside.
But it must have to be with an update from Xcode, because I googled for it, and last time before I closed it, I tried it out, and the function was all right, and today I reopened it and I got this error.
Okay, interesting. You updated to Xcode recently?
Yeah, I got a message and did a automatic update in the night, I think 2 days ago or something. But I don't really get it to how to fix it.
Interesting. Oh, just a second, let me check this here. Do you use any custom views?
No.
No, not really.
No, not.
How it looks here. Just outlets. And can you scroll further, please?
Yeah, this for every button, the same.
Yeah, I would ask you to try this. So when you go to the file option on top, then choose should be some workspace settings, project settings. Yeah, this
project settings, yeah.
And yeah, you see this derived data.
Oh,
You
this
should
one.
go in there, yeah. Open the folder.
The derived folder?
Yeah, this one. And empty it. So that's basically what is getting generated when you build a project. And sometimes when you're getting some weird build issue, sometimes it helps to clean this folder and try to rebuild, and often it goes away.
Okay, so delete all folders in here.
Yeah. And now you go back to the project, to Xcode. Yeah, this is done. That's it. And then press Command B, so it builds the project. And let's see if it helps. Also, can you open your storyboard? But they're still there. Can you also go on top to the editor? There should be refreshing. Refresh all views on the bottom.
Oh, here, yes.
Oh, really doesn't want. Then open product and press clean build folder. It's really weird. It should remove it, at least for now.
Maybe I should close the project and reopen it, or?
Not sure. It really should go away when you clean the project.
Okay.
Can you please send me the project? I will try myself.
Yeah, okay.
Yeah, Lucas, I looked through your project. There is some issue for me as well, but seems to be different. I will look again a tiny bit later. Now let's start with the next slide deck. We will start with testing, and then I will look again into it, and I will help you.
Okay, thank you.
Did everybody else manage to do the tasks?
Yes.
Sounds good. If anybody else have any questions, just let me know. And yeah, for now, let's start with testing. I will share my screen. Do you see it? So we start with testing. First, why it is really important to always write tests for your ERP is first because it serves as some kind of documentation for a more complicated logic. For example, you have really a complicated module which performs some complicated logic, and you may think that now it is clear to you what it is doing, but when you're working in a bigger team and when there are always new people are joining the team, it is really helpful to have tests so that you could look through them and see what behavior is expected from your tests, from your module or class or whatever. So it is really helpful as a documentation, and also it is really helpful when you continue developing your app, let's say for really extended periods of time, for years, and you add additional functionality on top of what existed back then. And you also may refactor something to make it more flexible or maintainable or whatever. And often you may not know yourself, or for example, when another person joined the team and they actually don't know how something worked 3 years ago or something. The tests is exactly the thing which would notify you immediately when something went wrong with the refactoring or building a new feature. Sometimes you may create something new and be not aware that you actually affected something that existed before that. And yeah, tests are really important in this sense because like when you have regular release cycles, you may miss some older features, so like smaller ones which you don't really test regularly, and you may realize that something is broken for really long and you didn't even know about that. So yeah, that's why tests are really important to write. Often it is recommended to follow so-called pyramid distribution of tests. Basically, this approach describes how you should distribute your tests. So how many of each type of tests you should have in your app. So first we will start with unit tests. Yeah, as it comes from the name, unit tests. Tests is just a single unit, so it can be a class, for example. Unit test is supposed to be really independent. So when you unit test some class, normally you shouldn't instantiate any other classes. So it should be really isolated and it shouldn't be affected by anything. Yeah. Normally, you don't have any network calls in unit tests, any database access. It's just really this class, and you really just verify the behavior of the class itself. The integration test would be something, it is really similar to unit test. So you would use exactly the same tools. Everything would be really similar. But in the integration test, you verify how a couple of units or classes or modules, something, how they are working with each other, so how they're integrated together. Yeah, an example would be, for example, you want to verify that when you perform a request to the server to get user data, then you check that user image is loaded in the database or something like that. So it's kind of two different modules, and you just check that when you do something with one of them, that another one is updated or modified in a way you expect it to be. And then there are end-to-end tests or UI tests. These are way more, they require more resources to run. So unit tests are really fast to run. It just takes milliseconds to run them. And UI test is something what can take minutes to run. That's why you should have the least amount of UI tests in your project. Let's look in more detail. Yeah, let's talk about the best practices for testing. This is the recommendations from Apple. So first, your test should always run quickly. You should, try to aim for it so that when your tests run automatically on CI, for example, so that you don't need to wait for too long for all tests to run through, and the faster the better. The tests should be independent, isolated as much as possible. Again, even when you're writing in integration tests, you should aim to only check the specific integration between specific modules and not everything. You shouldn't set up everything as it would be in the real life situation. Just instantiate these two classes and check how they work with each other. Tests should be repeatable. So if you run your test 10 times in a row, 20, 100, the result should be the same all the time if nothing changed otherwise. If the result is not predictable and can change, it means that the tests are flaky and it's not really good test, because they cannot really show you in a stable and reliable way that something is wrong or not wrong with your code. Yeah, tests should be fully automated. Yeah, timely. Ideally, tests should be written before you write the production code they test. It's called test-driven development. It is not always how it happens in real life. Often you may join, for example, a team, and at some point they didn't have any tests, and now they started writing them, and obviously there will be some bunch of code which is not really tested, and you need to write tests afterwards. But ideally, you write a set of tests, and then you make your code pass these tests. This is ideally, but as I said, not always happens. Yeah, tests should cover core functionality, model classes, methods, their interactions with the controller, most common UI workflows. So when you're writing UI tests, you shouldn't really cover every screen possible in your app, because when they are pros and you have 100 screens, you shouldn't write a UI test for each of the screens. It's too excessive, and it will take, I don't know, 2 hours or something to run the tests on CI. Yeah, boundary conditions, some edge cases, and bug fixes. This is actually a really nice and recommended practice to do. So, for example, you already have something that functions well. It is tested, but then somebody finds a bug in there. It's really nice to first write a test for this condition, make sure that it fails because there is a bug, Then you fix it and make sure that the test is green, and keep this test in there to make sure that this bug never happens again. This is a really nice practice to do. Yeah, on iOS, when you're writing tests, you use Xcode test framework. Really convenient and easy to use. Basically, you just create a class which subclasses from Xcode test case, and inside you can just write as many tests methods as you want. To actually make it work, you always need to use some assertion method in the end of the test to make sure that the functionality actually meets your expectations. For example, you would use assert to just verify some Boolean expression. So when you assert and something returns false here, it will fail. You can also use assert true or assert false if you expect false. Again, it will false if something returns true. You can also verify if something is nil or not nil. You can also check two values, if they're equal or not equal, or less than or equal. So for example, you expect that, let's say there are 5 entities of something in your database, and you just verify that it is actually true, that your repository saved all the entities correctly. And you can also sort whether something throws an error or doesn't. And yeah, as I mentioned, we are going to start with the unit tests. Yeah, each unit test should assert the expected behavior of a single path through a method or function in your project. And to cover multiple paths, you should write one test for each scenario. So in general, try to aim for as many unit tests as possible, because they're really lightweight, they're really fast, and yeah, it's good to have as many of them as possible. Normally, you arrange your test method in the following way. Actually, it's not really specific to the unit test only. You should use the same approach for the integration test. So first, you need to set up everything, create any projects or data structures which you need, replace complex dependencies with stubs, mocks, so that you really isolate your class from everything else. Yeah, adopting protocol-oriented programming ensures that relationships between objects in Europe are flexible to enable substitution. Yeah, I think I mentioned on one of the lectures, it's nice to just pass a dependency to some class as a protocol, so that for tests you can just replace it with some mock implementation of this protocol. So this is arranging of all the dependencies, setting up everything, preparing for the test, and then act. So call the method or function which you're testing, using parameters and properties which you set up earlier, and then assert. So use some methods which I mentioned before for asserting the result. So here you created, for example, an instance of the class. Here you called some function which you're testing, and here you compare the result of this function to some expected value. So here is an example. We have a stack data structure, and we are going to write a unit test for that. Unit test because there are no dependencies to this class, to this structure, and yeah, it's a really easy example of something what can be unit tested. Stack is pretty much like an array, but with a really specific behavior. So when you add elements to the stack, they kind of imagine imagine just a vertical stack, and they just stack on top of each other. And when you want to access the element of the stack, you access the one which was added the latest. So when you remove them, they are getting removed from the last to the first. Here's the way it's implemented. And no, it's too far away. Yeah, and here's the test for that. Let's do that in Xcode. Yeah, here's stack implementation, which I showed you before. Now we are going to Now we're going to create a new target for the test. Xcode always offers you a bunch of templates. We need a unit test bundle. So unit test bundle is also fine for the integration test. And if you are writing UI tests, you would pick this one. So yeah, let's say unit tests. Here's the test. We can create a new class. So let's say stack tests. Here we pick unit test target, because we don't want to compile these test classes when we are just running the project, the app. So here it is. Stack tests. And we should always subclass from the Xcode test case. So let's first import Xcode test framework. And now we can write this. So for example, let's verify that the stack is empty when we create it. Also, we need to make sure that the class which we are going to test is in the target testing. Otherwise, it won't see it. Here, as you see on the right side, there is target membership. Section where you can pick to which targets you want this class to belong. So that means that this file will be compiled when you run the app and also when you run tests, which is expected for this case. So the first case, the first step is setting everything up. So let's just create stack. We actually, yeah, it should build and then it should sit. So we create an instance of a stack, and then we want to assert that it is empty, so that there is nothing in it when you just create it. Assert stack. Let's try to run it. Just a second. First, it's just property, yeah, but it doesn't sit. yeah, the first run takes a bit. So as you see, the test is green. That means everything is fine, but let's see how it behaves if something is wrong. Yeah, it failed. So we can cover most scenarios. As you see on the side in this panel, you can also see the list of the tests which you have, and you can run a bunch of them at the same time. Yeah, so let's also verify that when we pop the latest element, that it is nil when the stack is empty. Assert nil. Yeah, pop is a mutating function. So let's define it as mutable variable. Yeah, all of them are green. And yeah, as I mentioned, you should aim for as many unit tests as possible. So the first ones are rather simple, but then you can verify a few more complicated examples. Because, for example, when you just call all the functions separately, they may work correctly, but when you have a sequence of them, there can be something can go wrong, so you can verify the sequence of them. So let's write a test like this. Yeah, we want to verify the order. Yeah, to make sure that stack is actually a stack, not something else. So this is still setup. We want to add a few elements. And what we're doing next is we're asserting each of the further methods. So we want to verify that suitable, so that when we pop the latest element, that is 3, then it should be 2, and should be 1. Yeah, it works. We can also check that after we popped all the elements, that the stack is actually empty, because that's what would we expect. That's what we would expect. And as I mentioned, you can either run tests one by one or all together for the whole class or for the whole target. Yeah. Yeah, this is another example. Let me see what this. Yeah, this is an example of a bit more complicated unit test. So, for example, we have a controller which has a dependency to the repository. And the controller doesn't do too much by itself. It tells the repository what to do, to add element to the database, or to remove it from there. And it can also specify some sorting behavior, and that's it. Here we have the protocol itself for the repository. As I mentioned, really important to pass the dependency as a protocol so that when you have actual app running, you would pass the proper repository which actually accesses the database. And for the tests, you would just pass some mock implementation of this protocol. And let's see how it would look like. Again, we created a class which subclasses from the test case. This is the most important thing. Otherwise, Xcode won't recognize your class as a test. Then we can also override setup and teardown methods. This is the methods which are being invoked before your test starts running and then afterwards. Here we also make our test conform to the protocol because we are writing a unit test for the controller. So we need to mock all the dependencies of the controller. In this case, controller has only one dependency to the library repository. So we make the test to conform to the protocol. Here we implement the methods from the protocol. So add, remove, and fetch all the books. So in the real life situation, the repository would access the actual database or make a server request or whatever. But for the test, for the mock, we just have an array where we are going to append and remove the books from. And here our it's implementation of the protocol, and now we are going further to actually write tests. First, we are going to test that when there was nothing added, the controller doesn't return any books. So basically, we test if we only invoke methods from the controller, we don't do anything directly with the repository. Controller uses the repository, and we want to make sure that it works correctly. So in this case, we verify that controller doesn't return any books in the beginning. Then we want to check that when we actually add a book to the controller, that it returns this book when we fetch all of them. Again, we are adding everything via the controller, not the repository. So we added the book, and then we use the assert method to verify that the fetched books, which controller requests from the repository, actually equal to the book which we added. Here we test the removal. We just put 2 books into the books array, which repository uses as a source of data. And we want to make sure that when we remove a book from the controller using the controller, so this is test for the remove function, we just verify afterwards that only 1 book is left. We also can write tests for the sorting. Again, controller in this case is responsible for the sorting, and we make sure that although in our mock database, so-called, the books are in this order, we want to make sure that when we fetch them, the sort is correct the way we expected it. As you see, it's different here. And we also verify that sorts by author also works same way. You see, we call the function to update the sort, the way we sort the books, and then we again verify that the books are sorted correctly. Now let's take 10 minutes break, and then at 11:20 something, let's continue with integration tests. So see you in 10 minutes.
All right.
So now let's continue with the integration tests. I have just uploaded the slide deck, this one, testing slide deck, to the course. So if you want to look at it, it's already there. So now we continue with the integration tests. As I mentioned, they're really similar to unit tests and pretty much follow the same pattern when you first arrange, so set up everything, then you act on it, so you call the functions which you test, and then you assert the result. The difference between a unit test and integration test is the scale of it. So unit test covers a very small part of your app, often it's a class, and integration test verifies the behavior of a larger system, so a combination of classes and functions. So here is a similar example. Actually, it is the same code from the previous example, but now we also have a tracker here in the controller. So when user adds something to the library or removes, we also want, as a developer, we want to know it to see how the feature is doing and if it's popular or not, and how it's doing. So now you want to test whether library controller works correctly in combination with tracker, so that when you do something in your controller, so that the correct event is tracked. That's a pretty common example of the integration test. So the setup is really the same as you see again with subclass test case. We're also going to again mock the repository, because in this integration test we want to check how controller works with the tracker, not with database. So we don't need to pass an actual instance of the repository. We are going to mock it again. So in the setup method, we created an instance of the tracker and of the controller. Here's the mock implementation of the protocol. And now we can actually write tests. So again, the first step is always arranging everything. So we created a book. Then when we are testing something what is not synchronous, so for example, you added a book to the library and then you track something, and potentially this event can be tracked maybe in half a second, so not really immediately. In this case, when it's not synchronous, you need to use expectations. So in this case, you create an instance of the expectation, you provide some description. So what we expect is that when we add the book, that the event is tracked, book added. So you see, if we go back, when the book is added, we track book added event. So event has action and has parameters, and we want to track that book added event happened, and there are parameters, title of the book and the author. We create expectation, and then we observe the tracker. So this tracker and also this observe, it's to say that it is not really Swift API or something. It is just something what comes from this tracker. So depending on what SDK you use for tracking, or if it's something what you created yourself in your team, it could be something else. This observe is kind of made up method, and that's it. So in here we want to verify that when event is actually sent, so this this closure which we pass to observe is will be invoked when the event is tracked. And we want to make sure that the event has the correct action and has the correct parameters. We check that, and if it is true, we say that the expectation was fulfilled. Otherwise, we call just fail. In this case, the test will be marked in red color, and it will say that the expectation was failed. And here is the second step. It's act. Now we add the book to the controller, and then we are waiting for the expectation to fulfill. Again, as you see, we test the controller itself. So in the integration test, you test one module or one class, and then you verify that another module or another class got updated or reacted the way you expected. And if the correct event was sent, the expectation will be fulfilled, and yeah, the test will pass. Here is the same test, exactly the same thing, but for the removal. Again, we created the book, created the expectation that the book removed event is tracked, and yeah, if it is tracked correctly, we are fulfilling the expectation. Here is the second step, we remove it and then wait for the expectations. Yeah, as I mentioned, you perform actions on one component and verify the result on another, so that you are verifying the correct communication between the two components. Yeah, here are more examples on that. That when you update the sort way, that it's also tracked. And yeah, as I mentioned, there are also UI tests. These are the tests which you should have the least amount of in your project, because it takes a lot of time and resources to run them. So basically, you should cover the main scenarios in your UI tests. So for example, in Runtastic, we have training app, we are working on it. And basically the main, the core functionality of the training app is of course doing a workout. So doing a workout should be covered with UI test always, to make sure that, I don't know, every time we merge something to develop, that the main functionality is still there, and we will find out if something is wrong early on without our QAs testing it first, which would take more time. Yeah, as I said, it takes a lot of time to run them. They look a bit different from unit tests and integration tests. They're still organized as subclasses of the test case, but there is a bit different API which you're going to use. Basically, what you're doing, you're really, like from the user perspective, you're clicking through the app and make sure that the app does what you expect. So for example, in the training app, you would say, okay, first click workouts list button, then click on specific workout, then click start workout, then swipe through the exercises. So your UI test needs to do all the actions like a user would do that. They're a tiny bit more complicated to write, but otherwise not too hard. But we are not going to cover them in this lecture. Now I would ask you to try to write a unit test, either for the project which you already have, like either for the tasks you implemented today or earlier, or you can just write some small class which has some functionality and cover it with a unit test. I already shared this slide deck, so that if you want to look it up again, you could. And we could take maybe 20 minutes for that. Do you have any questions?
I have a question, but not related to tests.
Mm-hmm.
It's about more about API endpoints and yeah, what is more used right now, or I don't know, or what you use at Runtastic for endpoints, REST, GraphQL, or gRPC?
So we actually have next, I think the slide deck, which is right exactly after this one. And we're actually going to discuss the APIs and how you perform all the requests from the iOS app. So it's just tiny bit in the future.
Okay.
Mhm. So yeah, try please to create a unit test target and write a unit test class to verify some functionality. Like this. And if you have any question while doing that, let me know, please. So how is it going with the testing exercise? Yeah, let me know if you have any questions on that. And also regarding the exercises which you need to hand in, I opened the exercise for the UIKit data slide deck. So I guess you should have at least a week to finish that, because you still have the exercise from the other UIKit slide deck. And then I'm also going to open the exercise for testing, but then there will be a longer deadline because today we finished a bit more than I planned. So for now, just finish the assignment which was before, and yeah, then start with other UIKit assignment. The testing one is not really priority right now, but you can start with that if you're faster. Do you have any questions on the topics we discussed today?
For now, not really. I guess the questions will come when we do the exercise more.
Yeah, but when you start doing the exercises and something is not clear, just send us a message, either me or Ralph, and we will explain everything.
All right, yeah.
Just really don't be shy, send us a message if there is something wrong or not clear.
I have a question, not really to the topics we did today, but more to the MVC pattern.
Yeah.
I'm trying to make to do the exercises, or rather the exercise we have to hand in with the MVC pattern, but without storyboards.
Yeah.
Normally this you would do it with storyboards, because storyboards are the views, then you have the controller and the models.
So the thing is, it can be a bit confusing with the naming view controller, but often to make it testable so that you can test all the functionality separately, you treat view controller as view. Because normally your view controller should just communicate to the storyboard or to the view variables directly, and then you would have other controller which actually, I don't know, accesses the repository or something like that.
Okay.
Yeah, so if it's, let's say, if it's some simple functionality when there is no complicated logic, you just do it in the view controller. But if it's something bigger, then it's normally view controller is just a view, and then there is another controller which performs as the controller component of MVC.
Okay.
Does it make sense?
Yeah, because with the constraints and everything, it's a little bit harder to extract it out of the controller. So that was the questions. But you could also, this is a question, could you also make a separate UI view where you make getters, so you get a reference to the things you want to control in the controller?
Yeah, always depends on the complexity of what you're doing. Because when the functionality grows, you cannot really keep everything in the view controller. First, because it is not readable, and second, it's not really testable. Yeah, and normally when you have your controller separated in a separate class, your controller shouldn't work with UIKit at all. So there shouldn't be constraints, there shouldn't be views, stuff like that. So your view controller has all of that, and then there's controller which just, I don't know, communicates to the repository or to, I don't know, anything else, maybe some server requests, whatever.
Okay, but how do you give the data to the view without having anything to communicate? Do you have separate functions in the view in the view controller that gets called from the view from the controller, or?
So you see here is in this. Do I still share the screen? Yes, still do. So here is an example. Here you have the controller. So it's just the controller, not view controller. And your view controller would have a variable for this library controller. And it would say, okay, here are the methods from the UI table you delegate, where you tell how many cells you want. And you would say controller, I don't know, fetch all books count. You know what I mean?
Okay. I thought it was the other way around. You would have a reference to the UI view controller and call it from the library controller. Okay,
Yeah,
okay.
it's kind of other way around. So this way, you see in this controller, you don't have any views, you don't have any view controllers, you don't have UIKit anything, and it's really easily testable. You can really easily write a unit test for that.
Okay.
But otherwise, if you make the connection other way around and you have UI view controller here, views or whatever, then you cannot really write a unit test because you would need to provide all of that, you know. Because you cannot really mock views or something. I mean, of course, you can just create them, but it's not going to be then unit test.
Yeah. Okay, and the second question is about the observer pattern. Is it common to use, because RX Swift, as example, uses this extensively? Is it common to use it, or?
Yes, it is really common, even not, how to say that it is not really a platform specific thing. So on Android is also a thing.
I know every language has, it's like a protocol. I don't know.
It's a pattern. Yeah, it's a pattern which is
right.
which can be implemented on in any programming language. Yeah. So, for example, what you also could do here differently, instead of having a method which returns books, you can have a variable for the books and make make an observer for the books and make your view controller observe the variable for the controller from the controller. You could do something like that, for example. Really depends. You can take any approach.
But are there any problems with memory? Because in some languages, it really makes memory management a lot more difficult, or it can, memory consumption is said to be higher with it. So
yeah, I mean, especially in Swift, you need to be careful with memory management. You need to make sure that when your view controller is being destroyed, you need to make sure that the controller is destroyed as well, so that all this setup which you have doesn't stay in memory after you left the screen. That's why you shouldn't have a reference to the view controller. So only view controller has a reference to the library controller, and this way, when the view controller is being destroyed, the controller is being destroyed as well, and yeah, everything's fine. But again, you need to be careful, of course.
Yeah. Okay. Thanks.
Mm-hmm. Does anybody else have questions? If not, then I guess we can finish for today. And yeah, again, I want to remind you, when you're working on the assignments and you have questions and something is not clear, just send us a message in Teams and we will explain everything to you. And that's it for today, and see you next time. Bye.